Hello. I hope you guys can hear me. If you can't hear me, just give a thumbs up in the comment section. And welcome to tonight's AR/VR MR Design and Evolution event. So we'll be getting started now. This event is organized by Dev Party. So we're a group of GDGs located within UK and Ireland who are looking to host events for developers by developers. And I'm your host for today. So my name is Pranav Nagarajan, and I'm a second-year electronic engineering student studying at the University of Southampton. And I've only recently moved to the UK because I come from exposure to a multinational educational environment, having lived and done schooling in India and China. So I've initially lived in India for my first 10 years of my life. And then I lived in Shanghai from 2010 to 2019. And I only recently moved to the UK to pursue my interest in electronic engineering. If you guys do have any questions regarding the event, feel free to always post it in the comment section, and I'll be more than happy to bring it up and answer it. So housekeeping, just some general stuff so you guys know what's on the agenda for tonight. So first, we'll have a talk by Julien on AR/VR on Android in 2021. And the second talk will be led by Mike, who's here to talk about UI/UX app design at Mixed Reality Age. And as I mentioned before, if you guys have any questions, feel free to post on the chat. And you can access our code of conduct in the link provided. And if you want to post anything on social media, feel free to use the hashtags GDG Dev Party, AR, VR, and MR. So let's get cracking. So AR/VR on Android in 2021, that is Julien Salvi's talk. And here is Julien. Hi, Julien.
Hello.
How are you doing?
Good, and you?
I'm great, thank you. Well, I look forward to your talk, and I'm sure all of our viewers tonight are eagerly waiting to see what you have to say. So good luck.
Thank you. So let me share my screen. All right, should be good now. Just let me a second. Here we go. Good evening, everyone. So welcome to my talk. So this evening I'm gonna talk a bit about AR and VR on Android in 2021. So I'm Julien Salvi. I'm an Android GD based in Paris, and I'm also a senior Android engineer at ARCore. So let's get started. So I'm gonna cover like virtual reality and augmented reality on Android. It's like kind of retrospective from 2014 with the beginning of cardboards, and nowadays with ARCore and some other cool stuff on AR. But first, I want to talk a bit about virtual reality on Android. So let's see how you can be like very immersive experience with virtual reality on Android. Just want to start with the quote by John Carmack about virtual reality. It's a moral imperative that we must create this. So virtual reality is fun, and it has to be created and bring to everyone. When you are creating virtual reality apps, VR apps, you have to be immersive. If you are on mobile or on desktop, that's the main point. Be immersive. The user must feel the atmosphere of your game or your experience to bring like something he already knows, and also bring your touch to the reality you are creating for your game. And especially the storytelling is important in VR. Just like it's not like just a one scene experience as you can see for AR. The storytelling like be very immersive, like a real game. Also go beyond reality. You can create some awesome experience, like, I don't know, for example, you can like set a DJ set in space and have a DJ battle around Saturn or something like that, up to your imagination. Bring your app to new levels. For example, if your app is just for consuming video content, why not consuming video content in a new, brand new theater in VR, so you feel the experience of theater, especially in these times. Also, be social, share your experience. My VR is also very good for interacting with people with voice and gesture. You can be very social. You might be far apart, for example, living in Canada and in India, and be very close by with VR. So it's all possible to do this on Android. So I be here, like, it's a bit of a retrospective here. So our VR started in Android. So it all started with Cardboard in 2014, created by two engineers at Google. Basically, just a cardboard and two lenses. There were just like a tiny SDK back in the days to do some prototypes and very, very small apps. Then in I/O 2016, the Google Vr Sdk came up, very specified for building a great VR application on Android, as well as Daydream. So the dedicated like VR framework for high quality VR apps, with a standard headsets made by Lenovo, or you can use your Pixel, but there were not so many devices compatible with Daydream. And then the golden ages was like 2016, 17, 18, and then in 2019, the Google VR SDK started to be archived by Google, and all the stuff inside the Google VR SDK started to be deprecated. But at the end of 2019, they released new Cardboard SDK. It's still maintained, but it's only like C++ and core feature with the NDK, and for Unity, the Unity game engine. It's not very like accessible for Java Kotlin developers as for Android developers. And in 2010, Daydream is discontinued, so no more Daydream, is no more maintained and no more supported by Google. So as you see, VR has started like to decline and not very supported by Google. And let's see what we have now for building the VR apps on Android. So what about the Google VR SDK? So it was very nice to work with. It was very easy to prototype and add some integration in your existing Android apps. So there are the awesome widgets to play 360 videos or panoramic images. It was a native SDK, so you were able to work with native with C++ or other more top layer with Java for an easy integration in your apps. But yeah, as I said, since November 2019, it's no longer supported by Google. It's a pity because it had a lot of good feature. So no more GVR. So what was inside it? So you can still use it. The repository is archived, but the libraries are still accessible. So you can still use it. And for example, on the one of the latest, the 180, You can use these two view, like if you want to easily integrate some 360 video in your Android app. It was very easy to integrate. So yeah, if you want to watch 360 videos or panoramic images, just play with these two components. But yeah, deprecated. So it was like this. In your activity, you were able to add these widgets, watching videos with as a 360 video. So you can tap on it and go to the cardboard mode or watch it as a 360 on a sphere. Or you can also use the SDK to build your own video 360 and the 360 video player. It was up to you. And also, yeah, you were able to use the GVR for prototyping for playing videos in VR. So, for example, here a little prototype like to experience videos in a VR environment, like in a theater, but without all the 3D stuff around it. Then you also add the possibilities and the capabilities to develop for the Gear VR. So what about the Gear VR SDK? It was mainly focused for Samsung devices. It was great because it was dedicated for Samsung devices, so very optimized for them. And it was very popular back in the days. It has a lot of performance back in the days, but then Oculus decided not to support anymore the Gear VR. So yeah, you can't now develop for Gear VR. So what's for VR on Android? What's remaining? What's remaining is the Cardboard SDK, maintained and developed by Google. It's a native SDK, so purely in C++ for Android, iOS, and Unity. If you want to deal directly with the native library for Android developers, it will be hard to have a prototype of something, because you'll have to deal with C++, OpenGL, and maybe Vulkan and some other stuff. So it will be hard to prototype directly with the SDK. But you can use the version for Unity and take advantage of the game engine to develop VR application on Android. And it's actively supported and maintained. Though the last commit is just a few days ago, so they are actively improving and adding feature to this SDK. So yeah, if you want to build some VR experience on Android, go for the Cardboard SDK. And if you want to target a lot of devices, of course, yes, go for it. Another one, so Gear VR was deprecated because Oculus released the Go and the Oculus Quest. So these are standalone headsets. It's probably the best one on the market for standalone headsets. So you can build here high quality VR apps and on high quality VR headsets, and so you have some controllers. So it's not like the Cardboard with little interaction for your application. With these controllers, you can get your experience much more better. It's a native SDK for Android, so as well you have to deal with the NDK and C++ if you want to go only with Android development. But it has a great Unity and Unreal support. So if you want to go for game engine, you can go for both of them, Unity or Unreal. Yes. So on Android for now, in 2021, it's Cardboard is still a thing, but not likely to maybe last long. It's supported, but for how long we don't know. There is no talk at the next Google I/O about VR, so it's here, but for how long we don't know. For Oculus, it's still actively promoting the Oculus Quest, especially the Oculus Quest 2. So if you want to go for VR, I would recommend to go for the Oculus Quest development. So now let's see how augmented reality went on Android. So start again with a code and a number. Over 600 million active users are using AR on mobile devices. So that's quite huge, and the AR market is growing like crazy. So it could be a nice investment to do some AR, depending of what you're targeting. But it has great capabilities for mobile experiences. So, for example, for housing or real estate, if you want to visualize a chair or a couch or something like that in your apartment or house, it's very nice to have a picture of what it looks like on your home, in your home. Also, of course, for fun, like building for gaming and leisure, as you may notice here, the Pokemon Go application became quite popular and was a real booster for AR. Also for science education and industry, you can build great application for educations, like bring a solar system in your class, so show a lot of stuff, like also maybe a skeleton or something like that, to have more material. The explanation will be clearer, and maybe the student will be a bit more focused. Or it could be a new way to enjoy sport, adding some live stats with the AR. With so, for example, if you are putting some goggles in front of a game, you have maybe some nice statistics about the player with the game itself. So could be a nice augmentation of the real life, and also enhance your daily life. For example, this is the Google Maps application on Android. So you can set the AR mode for navigation. So you set from a point A to a point B, and your itinerary will be shown on the real life with some pin. It's a nice use of AR on mobile. So what we have for building AR apps on Android. So of course from Google we have ARCore, the main framework for developing AR apps on Android. You can find also Vr, which came earlier than ARCore. It's there for a long time, so you can build AR apps with this SDK. And also, if you have, you can use also Wikitude, which is quite similar to Vr. And if you like open source AR Toolkit, I will recommend the AR Toolkit SDK. So with these four framework, you can do a lot of stuff on Android about AR. So this is where the AR stuff started from Google. So back in 2017, the first commit on ARCore rose. So in beginning of 2019, I think ARCore ARCore 1.0 was released, and just after Synform was released. Synform is was as it's now deprecated, was a nice framework on top of ARCore, like to prototype very easily some very nice application. You can do a lot of stuff with them, and I'll detail this later. So as I said, in beginning of 2020, Synform started to be open source, so it's no more maintained by Google, but the Android community is awesome, and someone took forked the project and is actively maintain it. So to prototypes quickly AR apps with Android developer skill, it's very good. ARCore is still actively maintained. So the latest release of ARCore is the 123, which came up a couple weeks ago. And in the next Google I/O, there's one or two talks focused on the next feature of ARCore. So for Google, the future is more AR than VR on their side. So let's talk a bit about ARCore and Synform here. So ARCore and Synform are made by Google, which have many features like motion tracking, light estimation, augmented faces, and so on. It's easy to prototype with Synform, and the main advantage here is you can bring Android UI to AR. So you don't need like a fancy game engine to build to build a huge experience, to build a new UI UX. You can still use the one you are building for your current Android application and apply it to VR. It also has a support of 250 devices, a bit more. So you can target a lot of devices with ARCore. If you are building for ARCore only, your minimum SDK will require 2024, which is Marshmallow, I think. And if you're just building a part of your application, so if ARCore is optional, you can target 14 at least. And you also have to target OpenGL as free. And the Google Play services for AR must be installed on the device. Otherwise, ARCore and Synform won't work on your application. And also, you have to target Java 8 if you are building for Synform. So now let's see the core feature, the main feature of ARCore that allow us to build awesome application on Android. So there's augmented images, so which bring images to life with ARCore. So you can scan images with your camera. You can store up to 1,000 references of that image in the cloud, for example. So when you are scanning the image, so the recognition will be on the cloud. So when the image is correctly matched, so you will be able to start the 3D things you want to show, like have a 3D representation of what you are scanning, or for example, it could be scanning a poster of a film. It will show the trailer of that movie. It could be one of the use case here. And like to build all the reference images, there is a command line that will help us like to build this huge image database with ARCore img. There is also augmented faces, typically here for building your own filters. Like if you want to look like a dummy like me, like a fox, or so just like for fun, it's stupid and go for it, just for having fun. So it uses face recognition to map some part of your face into a 3D mesh. So you can place augmented assets on your forehead, left and right, on your nose tip as well, and I think there is another part, maybe close to the mouth. So yeah, if you want to have fun, you can play with it. And for augmented filter, also you can have a look at this one. So this is something by Facebook called Spark AR. This is typically for building filters come on. Building filters and some tiny AR experience. So it's a studio purely on the design part. So no much code required for building this filter of tiny AR experience. So back on the slides here. Yep. Oh, come on. Up, back. And now Cloud Encores. So Cloud Encores, it's very here for building and create collaborative AR experience. So you have your application installed on, for example, 2 devices. You have 2 players, and you want to share a data of a 3D object to the 2 players who are playing. So you can use the Cloud Encore for that. It will store the data of the 3D assets in the cloud, and it will be shared between the multiple users that are using the applications. So, for example, here, if you want to play some kind of virtual beer pong, so let's say you want to share the paint across the user. So each assets, so the data will be shared between the users, and so they have a representation on their own, but both of them can play together. So it's a very, very nice feature, especially for being multiplayer applications or games. So you can use Firebase for storing this data, or you can use your own solution for sharing the data across your user. There's also the depth API. So this is here for accurate mapping of the environment. So with the IRGB camera and the depth images, so it can map clearly the environment where you are evolving. So it maps the depth of your scene. So your 3D assets, if it's placed behind a box or a desk, something like that, it won't be rendered, or it will be partially rendered depending on the position. So that's a very nice feature for controlling the object occlusion of your 3D assets on your scenes. There is also the light estimation. This is to build more realistic AR experience. It provides detailed information about the lighting in the scene. So it's computed real time, and it enables to create very immersive and realistic experience with ARCore. You can set an environmental HDR or an ambient intensity depending on what you want. But it does a very nice estimation of the light, especially if you are outside or inside, and depending on the light sources you have on your scene. It's quite fantastic. Just a bit about SynForm here. So SynForm is now open source since March 2020 and no more maintained by Google. But the Android community is very awesome, and Tomagoris has for the project and is actively maintaining the library and making a lot of improvement. So if you want an up-to-date SynForm SDK, go for the fork one and not the one by Google. It also uses the filament library, so it's a library made by Google, like to load and render the GLTF assets. So, bit introduction of SynForms. With SynForms, you can easily create some basic shapes like a cube, a cylinder, or a sphere. To do so, you have to provide a center and a radius or size depending on the shape you are building. And each shape accepts a material. And what's a material? So it's a texture, so it can be an images or color or even a transparent color. So it supports both transparency for colors and images. So it's loading asynchronously, so it won't be blocking for your application. And so it uses the material factory to attach the generated material to the shape. Also told you that you can bring some Android UI to AR. So yes, for example, this is a card built with an XML layout, like we are doing it on Android classically. No Compose now. So yeah, you can build your XML layouts as you do for your Android apps, and then like inject this XML layout inside SynForm. It will produce like an AR 3D assets that you can interact with, and all the click listener, the uncheck listener, or any kind of interaction you used to have on your phone with these views are working as usual on AR. So it's pretty impressive and pretty good. Like you can bring your existing Android UI to AR. Also, you can play with existing 3D assets. You can import and play with GLTF assets if you want like a bit more complex 3D objects. You can also use the object animator if you want to animate your assets and like bring them to life with nice animations. So as I said, for loading GLTF under the hood, SynForm is using the library, the filament library. And if you want to know more, if you want to have more info and more resources about AR, go check the ARCore documentation. It's very nice. Also, Google has a lot of code labs about AR. I think it's maybe 5 or 6 code labs, so it's good code quality here. So have a look and check it. If you want some design guidelines, Google also provided some guidelines for building great AR experience. And I also made a code sample of SynForm where I'm building a ship in AR with SynForm. So if you want to have a look, feel free. So the last part of the talk here. So we saw that building VR and AR applications like with only Android developer knowledge with our C++, Java, and so on, it can be very hard and very difficult. It might take a lot of times to have a very good result. But if you want to be very high quality AR VR experience, you have to go with a game engine. And here I'll show you how Unity can help you to prototype and build high quality games or apps for VR and AR. So Unity, the game engine available on Windows, Mac, and Linux. So you can build 2D, 3D games with it, or AR, VR, and of course MR experiences. It's fast prototyping and fast scripting, so you'll use some C# here for your scripting. And at the beginning, the editor of Unity is quite complex. It has a lot of buttons, a lot of the learning curve is very hard at the beginning, but it's worth a try. So you can build like very, very good experience. And a lot of studios and enterprises are using Unity for building their apps. So it also has a great interoperability with native platforms, so Android, iOS, and even consoles like PlayStation or Xbox. And it supports most of the 3D and 2D asset formats, so that's not bad. So if you want to like build an AR apps with Unity, I would advise you to go with AR Foundation. So AR Foundation is a framework made by Unity, that allows you to build for ARCore, ARKit, HoloLens, and Magic Leap at once. So it's very nice if you want to target like multi-platforms application for Android, iOS, and also the dedicated headsets, Magic Leap or HoloLens. You can also take advantage of the Unity features, easily playing with 3D assets, having great animations, and so many amazing stuff with the Unity pipeline for rendering. It also is future-proof for AR apps because you can implement a feature even if it's not yet implemented, but implemented on another platform, so it won't be an issue. For example, here, if you want to play with light estimation, so you're implementing your feature with ARCore and ARKit, but when you are building for Magic Leap and HoloLens, it's not yet available, but when it will be, you just have to enable it for Magic Leap and HoloLens, and it will be there. So no more code will be added. So it will be handled by the AR Foundation framework. And so, as you can see here, for building AR apps for Android, the support of ARCore is very, very great. You can do a lot of stuff, even the encore, so like estimations, even the warecasting, even the plane tracking. So it has a great support for ARCore. If you want to get started with a very nice tutorial, I just had a look at this tutorial, the AR Foundation by Ken Lee on the Ray Wenderlich platform. It's a very good introduction for building AR application with Unity using AR Foundation. Another thing we came very recently, it's the Google Maps SDK for Unity. That's a very big thing and a very fun thing to play with. So you have access to high quality geodata from the Google Maps database, and it represents all the buildings and stuff. So you can render all the features like the woods, the building, the monuments, the road, even the waters. So you can have a very realistic and very immersive experience with the Google Map SDK for Unity, and so it's only available for Android and iOS, but you can definitely be great experience with that SDK and have a lot of fun with it. So what are the main features here alongside the building rendering and the terrain? You can take advantage of the road lattice to represent the road network of the maps you are rendering. It's a set of nodes and edges, so you can represent some traffic, have a traffic simulation here. You can also identify the intersection, so identify and install the road intersection, and provide it use the provided metadata from Google Maps to create some traffic simulation, for example. And also a very nice feature is the terrain elevation. Terrain elevation is there to add like a fully stylable 3D terrain for better immersion of your application. So the terrain elevation is integrated with the Unity terrain engine. And so it's generating as a Unity terrain types, and you can style this style as you want. You have full control of the style here, thanks to the terrain layers of Unity. And here's what it looks like here. Tiny videos of representing like a building in AR. So you can use this SDK for building great AR experience, like for seeing like a famous building here in Singapore. So it's a lot of fun, like to see what you can do with that SDK. All right, so building for Unity means you have to also build for Android, and with the Unity as a library, it will simplify the integration of the Unity games and experience you built inside your Android apps. So you can add Unity content directly to your Android apps with Unity as a library. So it's available since Unity 2019.3, and it has also a proper library integration. Before that, it was very hacky to bring a Unity experience to your current Android app. So now it's properly integrated. So it's only a full screen rendering, so you cannot like put a part of your screen or a part of your activity as a Unity game. It's full screen only. And it's only one instance of the Unity runtime, so you cannot run multiple games at the same time on your application. And you may need to adapt some plugins to properly work with your Android application. And of course, you have to think of the application size. If you are doing that, it might increase a lot of your app size. So think of maybe app bundle or assets delivery by the Google Play. There's a lot of stuff you can do for optimizing the size of your application. Thank you very much. It was very intense to talk about AR and VR on Android. There's a lot of stuff that will come for AR for sure on Android. VR, I'm not so sure. It's very cloudy for VR on Android, but we have the device, we have the power to do it with the current devices. So let's see what's next. And thank you for listening. If you have any question, I'll be happy to answer.
Whoa, thank you, Julien, for that brilliant talk. I personally really enjoyed the talk because it was really informative. And as someone that's new to AR and VR, I found it really surprising that there was 600 million people who use AR on their Androids, which is something that I found really, really cool.
Yeah, it's not only Android, it's like mobile. It's on mobile, so it's also iOS and maybe iOS Android combined. But
Right.
yeah, we are close to 1 billion user.
Wow.
It's like, yeah, you are playing with filters and something like that. You are using some AR on your mobile.
Yeah. Yeah, I think that's the market is really growing, especially with more and more smartphones having more features. Especially, in 2015, there wasn't many smartphones around that had AR and VR inbuilt into it, and in 2021, almost every phone has the capabilities for
Yeah.
facilitating such things. And personally, I really like the depth API, and I think I will research about it after this talk.
Yeah, especially Google has a very good code labs about that. If I can find the code labs here. Code labs here. Don't want to show it in French. Categories. Let's see, augmented reality, and yeah, here you can see the
Right.
code labs for ARCore that API. So it's very interesting to do it. It's very instructive.
Right. It's because the way that you deal with lighting, especially in AR, for me it's really fascinating. But
Yeah.
I guess there's more and more tools and SDKs that do that. So I just found it really cool. So let's get on to the Q&A section. So if anyone from the audience have any questions, feel free to post on the chat, and I'll be sure to ask Julien about it. So we've got a question from Alex here. So just display it. So Alex is asking if there are any statistics for AR performance or power consumption on modern devices.
I think there is some tooling for that for ARCore, and I remember using for VR. You have some live stats when building some apps, but I'm not sure. But I think there is some kind of tooling to check the to check the performance and power consumption.
Right. So hope we've answered Alex's question there. Greg here is asking if Ingress counts as AR. So just to give a little bit of background, Ingress is a game. I'm not sure. Please correct me if I'm wrong, but it's a game like Pokemon Go.
Yeah.
Yeah. So.
Yeah, it was like Pokemon Go is based on Ingress data. So it can be, yeah. For me, I count it as one of the first like AR apps on Android, like on the market, which was pretty popular back in the days.
So those are the questions we have currently. We'll just wait for another 30 seconds or so if anyone wants to ask any more questions. But yeah, I think that was really cool, especially learning about the different SDKs and all of the SDKs that are currently not facilitated in the market. So yeah, personally found it really cool. So I'm guessing that there's no more questions for Julien. So Julien, once again, thank you so much for giving this talk. And personally, I found it really helpful. I'm sure many of the viewers did as well. So thank you for coming.
Yeah, thank you.
So for the second half of today, we'll be moving on to the next part of the talk, which is hosted by Mike Trizio, who is here to talk about UI UX app design at mixed reality age. So welcome, Mike.
Well, thank you.
Thank you. How are you?
Fine, thanks. And you?
I'm good. Thank you. I wanted to ask you, where are you currently based in? Which country?
I'm in Italy, in the south of Italy.
Wow, that's great. I'm currently based in the UK. Julien is based in Paris and you're based in the south of Italy. So, we have a very international bunch here.
Yeah, that's amazing.
So I'm going to let you get on with your talk. And yeah, good luck.
Thank you. So welcome, everybody. I'm glad to talk to you about UI and UX app design at Mixed Reality Age. So first of all, who am I? I'm Antonio Trizio. My friends call me Mike. I'm a computer engineer. Now I'm the CTO of Whiteverse, a startup that works on VR and AR products. Our main product is a Scotty Expert, a software that allows to make remote assistance in AR. In my spare time, I'm the lead of GDG Bari. Bari is this beautiful city in Apulia, as you know, the hill on of Italy. In addition, I have a lot of different hobbies, as you can see in this slide. If you're interested in one of these, we can talk together in a different moment. So now let's go straight to the topic of this talk. First of all, what is a mixed reality app? So let's make a short demo. Now I'm switching from the presentation and I will share my phone. I hope that this operation will be fast. Stop sharing. Share screen. Okay. Okay, this is my phone. All right, perfect. And now I will start my demo. This is a bit of lag, but nothing. Oh, I think that is problem connection. Sorry, one moment. Okay, another time. Share screen. Okay, window. Here we are. Okay, now this is my mixed reality app. Now I'm looking for a surface. I will use my. Oh, okay. So I place my. Oh, I hope that you can hear even the main dam of Star Wars. As you know, May is the first month, so I created this little app, mixed reality app, with an X-Wing. Oh, okay, it is landed so much near me. Okay. So then I switch back to my presentation. Okay, share screen, Chrome tab. Okay, here we are. Perfect. You can see me. You can see my presentation. Okay. So this is an example. So this is a bad example because in this presentation there are a lot. In these demo apps, there are a lot of mistakes, but we will talk about them during this talk. So how can we make a good mixed reality app? There are a lot of developer environments to create a mixed reality app, like we have seen even during the talk of Julien. So briefly, the most famous are Unity 3D, Unreal Engine, but if you're able to work even without a 3-engine scene, you can work even with Android Studio or Xcode. So we have seen that you can use Synform for develop AR apps. So talking about the toolkit and frameworks, of course, we have ARCore for Android that was renamed by Google in Google Play Services for AR, but I prefer to call it ARCore. Then we have ARKit, that is the Apple framework for iOS. And then we have the Mixed Reality Toolkit by Microsoft that is made for developing on Microsoft HoloLens, the Microsoft headset. In addition, we have cross-platform frameworks like Vuforia or Wikitude. But our focus today is the design of the apps. So please allow me to take a deep in the past, talking about user interaction in games. So please write in the chat how many of you have ever played a football table. So if you think to the user interaction of football table, you have to think to the physicality of the object. You have to hold the splint, decide the strength, and you can take the ball from the table with your hand too. But what happens next? So in the evolution of games, we got Flipper. So now the game is under a glass plate. So the interaction happens only using the two buttons at the side of the flipper. At least you can give a pelvis shot to drive the ball. We lost a bit of physicality compared to football table. But now we can have a different kind of challenge because each flipper is different from the other. And at the end of this story, we arrive at Space Invaders. So this game established a posture, physical, and mental revolution. We lost a lot of physicality and a way of interaction. The game is completely under the glass. We have only few buttons, and it doesn't matter if you press them hard. But we earn a lot of different kind of games. So Space Invaders established the modern paradigm human being, monitor, and keyboard that could compare with the medieval one, human being, horse, and sword. According Italian philosopher Alessandro Baricco, it is the icon of the modern civilization. So what happened next? We got PlayStation, we got smartphones where the keyboard is virtual too, and mixed reality headset where we finally are regaining the relation with physicality. And we will see how. So another jump in the past, the augmented reality isn't a nowadays concept. It has a long story since Galileo Galilei invented the telescope. It was the first machine to augment our perception of the world. So it was a good idea, but as we know, there were some popes and bishops that didn't think the same way. Going back into the future, this is the immersive spectrum presented by Google. It is our map into the immersive world. We begin with the real reality, that is the real world that we can see with our eyes. Then we've got augmented reality, where we have the real world that is interpolated by a virtual layer, like the lens of a smart glass or the monitor of our smartphones. And finally, we reach the virtual reality, where we are immersed in a virtual 3D environment. In this context, it's useful to give the difference between immersion and presence. The immersion is an objective parameter, and it measures the feeling of being immersed into a virtual environment, thanks to the sensory information received by our brain. Instead, the present is more subjective and stands for the feeling to be involved in an environment regardless its virtuality. And now I will show you some examples. First of all, obviously, VR. In this context, immersion and presence are bounded to each other. A virtual environment aims to replace the reality. Therefore, the immersion is the key factor needed to ensure a good level of presence. In augmented reality, we have a virtual layer that overlaps the reality. The presence improves with the capability of the virtual layer to be bound to the reality. But what does it mean? So we introduce mixed reality, where the device has a certain degree of understanding of the surrounding environment. Now, I imagine the question mark that is appeared over your head. What is the difference between augmented and mixed reality? So this is my home, and if I put a virtual tennis ball on the table, in augmented reality, the ball hasn't the real perception of the table. And when it arrives at the end of the table, it continues to fly in the air indefinitely. Instead, in the mixed reality, the ball recognizes the surface of the table and it falls when it reaches the border. The difference is into the reaction between reality and virtual layer. And we can have this kind of experience even on smartphone, tablet, and headset. But what are the rules that matter in the design of a mixed reality app? We can divide these rules in 4 categories. So, first one is user environment. So, first rule, we have to choose between 3 kinds of scale of our experience: table scale, room scale, world scale. So what will be the dimension of our app? I will play on my table, like chess. I will play on room scale, I don't know, like mini golf, or I need world scale playing, I don't know, like Pokemon Go. Second rule is the experience size. We have to include realistic screenshot before starting the mixed reality experience, because one of the questions that the user usually made is how much space do I need to run the app correctly? Because like in this case, the playfield can exceed the room dimension. So we can use virtual preview in app to show how much space the user will use, like I don't know, ghost image or something like that. Another rule, we must play with multiple surfaces. We can recognize 2 different surfaces, and for instance, let the frog jumps from one to another surface. At this moment, there are problems with the recognition of translucent and reflected surface, but I think that frameworks like ARCore will improve this thing in next future. There is an old film that I love that was an old version of Godzilla that has the claim size does matter. So in mixed reality, it is the same, because the use of large objects can encourage the user to move around them. So you have to encourage the user to move around the scene, and don't let be stand on their feet always in the same position. Lighting is a great problem for AR, because in a 3D real scene, we can have ambient lighting, reflection, shading, shadows, specular highlight, and it's a great problem. Takes all of these lighting clues and put them on the 3D model to make them appear more real and more real in the space. But in frameworks like ARCore helps us for this, because since the 1.4 version, there is an API that is working on the light. We have 3 different light, main direction light that helps with placing shadows in the right direction, ambient spherical harmonics that helps model ambient illumination from all directions, and HDR cube map that provides specular highlight and reflection. So you can see in the last image the result of the 3 light API bring together. But how can Google make this? Obviously with machine learning. So imagine this guy on the left. So, oh, sorry, one moment. Okay, Google, stop. Oh, sorry. Imagine this guy that is sampling the environment, going around the Google campus with this kind of crossbow with, as you can see, these 3 spheres made by different materials that absorb the light in different ways. So in using and collecting this data, we can have this new API for lighting. But the light can be also our friend, because we can use the intensity of the light as a trigger. So based on the intensity, we can turn on the light of the city, like in this example. But our experience are awesome, but with our friends are even better. So we can synchronize the experience between 2 smartphones with ARCore, for instance, with AR anchors in this way. So looking the same from the same angle and sharing the visual clues identified. This is in this way, then we can move around the room and play on the same scene. Now, second category of rules, user interface. First of all, we have always to remember the orientation of our environment. Because, for instance, Unity 3D have the assets in a different set instead of ARCore. Second one, this is a concept mutuated from VR, is the object position. We have three zones. The first one is the IP, that is the interaction plane, and is the distance 50 to 70 centimeter from our body. That is the distance where we can interact with our hands on button, and that is the area where we can place the buttons. So then we have the mid zone, where we can put virtual objects, and at the end we have the legibility zone, that is the zone where we put the content of interest, like text, images, or other object, plain object that we have not to interact with. Then we have to put, we have to set the boundaries of our app and limit the object placement by the user. So as you can see in this GIF, we allow the user to place the object in the green area, and if he places the object in the red one, then we put them back in the green area. Another rule is the use of off-screen marker. So as you can see, even in other app, to let user track the off-screen movement of object, we can use directional marker. By following those marker and moving around the user, we can follow the bird, as you can see in this GIF. And this is the same kind of experience that you can see on Google Maps, AR Google Maps. Then please avoid unexpected full screen takeovers. So avoid pop-ups. They are bad in 2D. I don't know why they should go in 3D. Then target size. That is the target is the area that we can click on. So we must maintain the target size that is easy to tap on. Create the user interaction that are simpler and quick. As you can see in the animation, the ball on the right, the tapping area that is drawn by the dotted line never decrease its dimension, while the ball does. So in this way, we can tap even on small object. So screen UI, please maintain it minimal. Put on only the right object, only the needed object. Don't be excessive. Then we have user movement. So we have to encourage the exploration by our user. So we can put a frog behind another object. So put the verse of the frog. So in this way, the user will go around the sphere. And in this way, we reward our user for exploring the world that we created for him. But we have a little problem that now is resolved by Deft API, that is occlusion. Occlusion occur when we want to hold AR object behind the real ones, and we have to deal with the depth of the environment. So now, as you can see in this second video, and as you can see in the talk of Julien, with ARCore we solved this problem. Another rule is guarantee the ease of access. So if you are developing an utility app, let user flip around the object to examine them from every angle, and in the way they can even enlarge the graphics. This is one of the most important rule. So I suggest to avoid encouraging user to work backward, because you don't know where the user will use your app. Another rule is to make the user uncomfortable when they enter in a place where they shouldn't be, like inside an object. So you can use a different material, you can use a different sound, but you have to give this kind of sensation or feeling to the user. For category, we have object manipulation. So we must guarantee touch interaction, of course, even on smartphone or smart glasses. So we have to allow the user to drag, pinch, and twist, move, scale, or rotate the object. The more the user can interact with the AR environment, the more it feels real. Then we can provide a screen gallery with several objects to increase the experience of our user. So we can grab object from a gallery. So as you can see, this is a linear layout with a bit of opacity, and drag the object into the scene. Then we can use reticle, because in this way reticles can be a good solution for grabbing small or distance object. User can use a reticle to pick up the object they need without covering up the object. Then presence selection. So reticles make it easy for user to move small objects. Don't force a user to try and tap a tiny object on screen. Instead, help them with the reticle. Then virtual weights. So use virtual clues like this raycast, that is this white line. Use raycast curve to make object feel heavy or light. So in this way, we can create the illusion of physical weight using your tool. It's another way to immerse user in your virtual environment. So to sum up, we have a new interaction paradigm. We have seen what is the immersive spectrum. We've seen the difference between VR, AR, and mixed reality. And then we have seen the 4 kind of rules for developing a design, a good mixed reality app. So user environment, user interface, user movement, and object manipulation. So now I want to share with you another of my samples. I hope that you have recognized the font. So I've realized a simple app that simulate the sorting app from Harry Potter. So the first version of the app use augmented images, but then I developed another version with augmented images. So now I switch back the presentation to my phone so I can try the app. Okay, stop screen, then share screen. Okay, Chrome. I try to open the app before. Okay, perfect. Where is window? Okay, share. Okay, you can see, yeah. Okay, so now here the phone, the app can recognize my face, and I put I anchor the hat on the face recognized, so I can move my head. As you can see, there is a little material that is transparent that allow me to show the front of my face, and then I can click on the app.
Gryffindor!
Oh, cool, Gryffindor! And then I can take a screenshot even. Okay, perfect. So this is the end of my presentation. I think that we have some minutes for Q&A session.
Thank you, Mike, for that very, very detailed talk. I really enjoyed the Star Wars part of your talk, and I really found the music really cool. I also enjoyed the end where you turned, the Harry Potter hat into a reality. I thought that was really cool. I wanted to ask you about one thing. I found the occlusion problem really interesting, and especially with dealing with depth. So, do you think that more and more AR VR apps, like for example Snapchat, are overcoming this occlusion problem or not?
So as you can see, the first one that dealing with the occlusion problem was Niantic with Pokemon Go, but then ARCore and ARKit include it on their framework. So I don't know. I really don't know if Snapchat framework has an occlusion feature because as you know, there are a lot of frameworks, and obviously Snapchat and Spark AR are the best one for social sharing. So I hope so, but I will. I think that I will make some experiment in the next days.
That's really cool. Also, we have one more question from one of our viewers here, who's asking, what does LH stand for in the areas?
Okay. Interaction plane. Okay. LH is the zone where you can put context, that text, image, all the content that you want that the user can read, but not to interact.
Yeah, that's really clear. So I guess we'll wait for 30 more seconds if anyone else has any questions. Yeah, I think I really enjoyed that. I also found the virtual weights part of your talk really interesting. The stone, and the stone dropped quicker than the feather. I thought that was really, really cool. So yeah, I look forward to researching about that after this talk.
They are little things, but can make the difference into a good AR experience.
Yeah, they're very, very little things, but yeah, they look way cooler, as with your demonstration as well. So it seems like no one else has any questions. Well, anyways, thank you, Mike, for your wonderful talk. I really enjoyed that. I'm sure most of our viewers also enjoyed it. So thank you for coming.
Thank you.
So we are reaching towards the end of tonight. So if anyone else is interested in speaking, feel free to contact me by email, LinkedIn, or Twitter. Anyone that is interested in anything. So it doesn't have to be about AR or VR or mixed reality. It can be about AI. It can be about cloud, and so on. So if you're interested, please do get in touch with me. And likewise, we host these events every month. So we usually host them the second Tuesday of every month. This is the second Tuesday of May, and I guess we'll host it for June, July, and so on. So feel free to get in touch with me. And if you have any more questions, feel free to email me or email GDG Southampton, as I am the co-lead of GDG Southampton. So thank you. And last but not least, thank you all for coming. And I hope to see you all in future events. Thank you.